find the moment about the base point O. In this case, take the perpendicular distance as 4.35. To cut short your procedure, I have given the perpendicular distance, but let's see, we can find the distance also. Okay, my aim is to find the moment. So what is moment? Force into distance. But we have to be very precise, force into perpendicular distance. So how to find the perpendicular distance in this case? Here in the question, they have made some connection. This is some steel metal. It is fixed here, and they are applying some force here in this direction, in the 600 Newton direction. The magnitude is 600 Newtons, and it is making an angle 40 degrees from here. He is asking moment about O, because when you apply force like this, your force will rotate like this. So this is creating a rotation. That's why they are talking about moment. So simple, the formula is force into perpendicular distance. The force is 600 Newtons. One step is over. The second step is finding the perpendicular distance. What is perpendicular distance? From where? We have to, because if you see it in the plane, this body is rotating about the axis passing through O, perpendicular to the plane of paper. So our axis is OO. That is not visible here. It will be just like a dot if you see from the top. As I said, the distance is nothing but perpendicular distance. You have to draw it from origin and then keep on drawing so that it will meet the force vector perpendicularly. After that, you mark it as some point P. Then this perpendicular distance is nothing but the distance OP. We need to find that distance. Once you find the distance, in the question, I have asked you to take it as 4.35 meter. So once it is done, then your moment is simply 600 into 4.35, that is 2610. Remember, the units is nothing but the product of individual units. It is Newton meter in SI units, or it can be pound force into feet in US units. So remember the units. Based on the units also, as a smart tip, you can answer the questions. Now you can ask me, sir, Mr. Chandravardhan, the question is like this, the 2 meter, it is 2 meter here, it is 4 meter here, and no information is given for the perpendicular distance. Teach us how to find this perpendicular distance. Since I have selected the complex question, I tried to reduce this, but here the explanation is here. What the procedure is a bit, it's a type of geometry here. At first, I have drawn this line. Let me change the color here. At first, I drawn this line, and then what I did, I know only this distance, I know only this distance. But what I want this distance. And I have some angle here, this is 40 degrees. So somehow I have to figure out how to find this distance. So what is the first step I did? I drawn a line perpendicular to this, this OP here, so that it became two triangles now. Again, I drawn a line from here A to this point, then it became one more triangle. Now, what I did, if this angle is 40, then this arrangement will be perpendicular, so this angle will be 50. You guys don't worry, this level is a bit complicated. If you know FE is nothing but the fundamentals of engineering, this level of question will not be there. But if you learn the tougher way, it will be easy for you for simpler questions. So whatever it is a part of geometry. Then if it is 40 degrees, it will be 50 degrees. Again, if it is 50, as per properties of triangle, sum of all angles should be 180 degrees. So if it is 50, it will be 90, and then it will be 40, then only it will be 180. So if it is 40, again it is 50. If it is 50, if it is 90, it will be 40. Then it will be 50, and then it is 40. After that, finding each and every angle at each and every corner, I considered each and every triangle and try to resolve these distances based on the known distance 2 meter and 4 meter. So if I take this triangle OQR, if it is 4 meter here, this is a right angle triangle. As per the properties I have tell you about sin theta, cos theta, tan theta definition. If I know this distance, I can use the cos theta. So that OQ is nothing but OR cos theta. OR is nothing but 4 meters, so cos 40. So I got this distance. Half of the answer is done. Now I am left with PQ. Once it is done, I will add the both. I will get the perpendicular distance. To find the PQ, I will have to try. I have to take this triangle. But in this triangle, I have no known distances. I have only known distance in this triangle. So I will deep this triangle. Again, apply some trigonometry formula. Then I will get this formula. After getting this distance, then I will apply some trigonometry in this triangle, then I will get this distance, then I will add the both. So this is the step that is involved here, guys. Please go through it. This is very simple, just you need your patience and keen observance. That's it. So approach 2 here, what you was talking about is approach 2. Instead of doing all those geometry in struggling to find the perpendicular distance, instead of finding the perpendicular distance, they made the forces into the components to the known distances. We know the 4 meter, we know the 2 meter. So I want to make it as a perpendicular distance instead of finding the new perpendicular distance. So for that, what you do conveniently, if I take this 2 meter as a perpendicular distance, you can see that the 600 newtons is divided into components here. So the first component is, it is 600 sine 45. Again, I am cut shorting the pressures and deriving the components. If this is theta, this will be 600 cos 40. This will be 600 sine 40. You can see that here, this is 600 cos 40, 600 sine 40. Now, the force F is divided into two forces, F1 and F2. So obviously, the definition will not change. Moment is equal to, it will be now summation of moment due to two forces due to F1 and due to F2. Very simple. Now, if you want to find the force moment due to F1, the formula is always the same, the force into perpendicular distance. So, if I treat it as a first force, it will be 6F1 into 4 meter, because this is the force vector and the perpendicular distance is, draw the line perpendicular to it, and this distance is 4 here. So, it is 600 cos 40 into 4 is a one case. Other case, this is a second force. The force into perpendicular distance means just extend this line vector and then draw a perpendicular line to it. This distance, you know that this is 2 meter here parallelly. So take it as 600 sine 40 into 2. Sum these both two moments, you will get the answer as 2610. You will get the same answer as before. Here I got 2610. Here it will again 2610. So that's it, guys. If you are in some cases, finding this distance will be simpler than finding the two components. In some cases, splitting into two components will make your life easy than finding the actual perpendicular distance for the given vector. That's it. This is a case. These are the two different cases you can get in the question. Not beyond this level.
Facing the challenge of the FE exam, looking for a way to prepare smarter, not harder? Bhavanam's C2C has the answer. Introducing Bhavanam's C2C FE exam preparation program, designed for civil engineers aiming to pass the FE exam and excel in the USA. Wondering what sets us apart? Our expert team. Meet Mahendra, EIT and project manager, who knows the FE exam inside and out. K.N. Mathur, EIT and civil engineering master's graduate. And Chandravarthan, IIT postgraduate and top 422 GATE rank achiever. These experienced instructors have already helped hundreds succeed. Will you be next? In just 3 months, you will master all 14 essential subjects through live online classes held every evening from 8:30 to 9:30 p.m. Monday to Friday. But that's not all. For each subject, sharpen your skills with 15 dedicated practice questions and follow up with quizzes containing 45 questions to solidify your understanding. Prepare like a pro with 3 full-length, 6-hour mock exams designed to mirror the final exam. Plus, receive personalized guidance through one-on-one sessions with our expert instructors to refine your strategy. We understand balancing work, life, and studies can be challenging. So we have got you covered with 1-year access to recorded sessions and replays of live classes to catch up anytime. Here's the game changer. While others charge over $1,000, we are offering everything for just $350. Want an even better deal? Contact the number below now to claim a flat $50 discount and get it all for only $300. Enjoy a 100% refund if you are not fully satisfied within the first week. No questions asked. Our live batches starts fresh every month on 15th. Don't miss your chance to join. Limited seats available. Contact the number below to secure your spot and get enrolled
So the
today.
question is simply they are asking the final resultant direction, whether it is this or this or this or this. So to solve this, they did not want any magnitude. If you notice the options, they don't want much magnitudes. They just want the approximate direction of the resultant. So if we have two vectors, as I always been suggesting, go for parallelogram law, which says that just draw the given vectors and then draw the parallel lines forming a parallelogram. Then from the point where the two vectors were acting, from that point, draw a diagonal. Then the diagonal will represent the resultant. So obviously, this option D will match the question. Even sometimes, even if they ask you the magnitude, suppose this is 30 newtons and it is 100 newtons, and they asked you the magnitude of the resultant. Then also, if the options are in such a way that only one magnitude is bigger than the 30 and 100 newtons, and all other magnitudes are smaller than 30 and 100, then we can easily pick up the whatever magnitude. Suppose if its answer is, you can physically see it. If this is 100, if it is 30, then this will look like this. And since it is 30 degrees and 60 degrees, the total is 90 degrees, then this will be 90 degrees again. These are simply the perpendicular vectors. If they are perpendicular vectors, the resultant is nothing but under root of 100 square plus 30 square. You can do that way, or if you don't want to do such steps, it is 30, it is 100 and it is 30, definitely the diagonal will be bigger than these two terms, so it will be something more than 100 only. So if one of the option is more than 100 and other options are less than 100, then you can easily pick up the answer without putting your pen and paper and calculator. You can directly get it. So that's it. Now let's practice basically what are the reactions that will be gendered. Mark the reactions acting on the structural beams. I'm sure this is simply supported beam, continuous, overhang, propped and fixed. And here they did not give any load. If they did not give any load in the question, we will assume that load can be in any direction, like this, it can be movement, and so on. So whatever may be the load, based on it, whatever may be its direction, whatever may be its intensity, the reactions developed always depends on the type of support only. And finally, this reaction can be zero if there are only vertical loads. And that is secondary case, don't worry about it. But remember, the reactions developed depends only on the type of support, but not on the loads. As per that, since the first question is simply supported beam, as I said, there will be two reactions here at the hinge support. It will receive the moment. So two reactions, and here only one reaction because it has to restrict in this direction. So it has to apply the resisting force. So here 1, 2, 3. So in simply supported beam, there will be three reactions. Clear? Now coming to the this thing, the continuous beam. It is a pinion support. Pinion support, obviously two reactions, and roller support, there will be one reaction, and here it is a roller support, there will be one reaction, and finally there are 2 plus 1 plus 1, 4 reactions. And guys, if you are worrying about the direction of reactions, you don't worry about it. If for a given direction of loads, if the load is acting from top to bottom and bottom to top on movement and uniform distributed load, it is very difficult initially to fix the direction of the reactions. So initially you can assume any direction. You can assume that this direction is in downwards and this direction is like this. And finally, after finding the analysis using the equilibrium equations, suppose if you got reaction at A in the x direction is negative, then it means that whatever direction you have assumed is wrong. It is just simply opposite to the direction you have assumed. That is a conclusion you will get during the calculation. So don't worry about the directions, but it will be either this side or this side, but it will be along this axis and this will be along this axis for anyway. So coming to the next case, this is a fixed beam, fixed at both the ends, and there is some UDL acting. As I said, no matter whatever the load, here at the fixed end, there will be three reactions, 1, 2, and 3. Movement will be acting at the fixed ends. So remember this point. Here also, since it is a fixed support, 1, 2, and 3, and total number of reactions are 6. And here it is a prop cantilever. Here also at fixed end, there will be 1, 2, and 3 reactions, and prop and roller support 1 reaction. Total there are 4 reactions. So again, the overhang end, no matter what complicated the loads are, we have to worry only about the type of supports. Here, this is big hinge support. That's why 2 reactions. It is roller support, 1 reaction. So number of reactions are 3. Now, if you want to know much more about it, we will study about them in mechanics of materials. But I will give quick summary. If number of reactions are 3, we know for the 2D system, we will be having 3 equilibrium equations. Sigma fx is equal to 0, sigma fi is equal to 0, sigma m is equal to 0. So number of unknowns are 3, and number of equations we have 3. So then we can find all the unknown reactions. Then such beams in which we can find all the reactions using just the equilibrium equations are known as the determinate beams. Statically determinate beams. The name itself suggests we can determine the unknown reactions using the equilibrium equations. Suppose if you take this case has 4 reactions, but the science says, the engineering says, in a 2D case we have only 3 equilibrium equations. So 4 unknowns, but we got 3 equations. So one reaction cannot be found by simply equilibrium equations. Such beams are known as statically indeterminate beams.